Okay, so welcome everyone to the December Frictionless Data Community Call. It's great to have you all here. Today, we're gonna hear from Oleg, who's gonna tell us a bit about his idea of data package as a service. I'll let Oleg tell us more about that, but before, as usual, let's do a little round of introduction. I think that more or less everyone here knows each other, but it's always good to remind it. I can start and then we'll do a sort of like round robin. So I'm Sara Petti, I'm the community manager of Frictionless Data, and I'm really happy to be here with you today and also to have a chance to wish you a happy new year before the holiday break starts. And I'll pick Peter to go after me.
Hi, I'm Peter Desmet. I use frictionless data standards in biodiversity data and publishing a number of biodiversity data sets from INBO, which is based in Belgium. And I go and pick Edgar.
Hello, I'm Edgar. I work as software engineer in Open Knowledge. I work in the Frictionless project and a bunch of other Open Knowledge projects also. And I'll pick Francisco.
Hi, I'm Francisco. I'm a policy analyst in the state of Minas Gerais, Brazil. And I work with open data and budgetary data mostly. And I think it's kind of related, but I currently am the maintainer of the CCAN-R package, which is a position that I just recently took over.
Thanks, Francisco. Who would you like to go after you?
Oh, sorry, maybe Keith.
Hello, I'm Keith. I'm a postdoc at NIH, and I work on genomics data analysis. And I will choose to go after me, Aditya.
Yeah, I think Aditya cannot speak because she's listening through a bot.
Okay, then how about Dan?
Hey, I'm Dan Fader. I'm a software engineer in Philadelphia, United States. I work at a company called Civic Actions for the Centers for Medicare and Medicaid Services in the federal government. I work on an open data project that's based on DCAN, which is a software package that Aaron Couch created initially, and I will pass to Shashi.
Hi, I'm Sasi. I'm from Nepal and I currently work as a developer in Open Knowledge Foundation. I pass to Nikes.
Sorry. Hi, everyone. My name is Nikes Palami. I'm also based from Nepal. So I'm the community lead at Open Knowledge Foundation. So basically working closely with global open data community. So nice to meet you all. I'll pass to Aaron.
Thanks, Aaron Couch. Also based in Philadelphia, maybe about 4 miles or so from Dan. Yeah, I'm really interested in today's talk. It's also always interesting to see when people can package things in from open source tools and to consumable, more consumable tools. And so, yeah, thanks for hosting today. I think maybe everyone else is gone. Is there anyone else?
I think Nick needs to introduce himself.
Thanks.
Hi, Nick Kellett. I own a Canadian software company called Deploy Solutions. We've been interested in climate change software development for years now. And that's one of the reasons we got introduced to Frictionless, because there's a need to make sure that the scientific data and other data is valid. But lately we've been working with groups that want to federate their data. They want to send data across boundaries, geographical, organizational. And I think it makes that even more important. So they talk about the data mesh, and that's a concept that we started to explore. And I think that the data packages as a service is a very interesting topic for us. So I'm looking forward to hearing about that. And I don't know if there's somebody else who hasn't been picked. Ali, maybe?
Exactly. Ali just joined. Welcome, Ali. We're just doing quick introductions before Oleg actually has to still introduce himself, but he'll do that, I guess, and kick off with the presentation. Yeah, so Ali, if you want to quickly introduce yourself, and then... Oh, Ali left.
Too much pressure.
Exactly. I think Gabriel also just joined. Gabriel, can you hear us?
Yeah.
I'm waiting to pounce on people as soon as they join.
Here. Hello, everyone.
Hi, Gabriel. You're the last one. Would you like to quickly introduce yourself before we kickstart with the presentation?
Yes, Gabriel here from Brazil. I'm seeing some friends here, like Francisco, and we've been using Frictionless for some time, and I think that's it.
Great. Thanks, Gabriel. Ali, I saw that you reconnected. I want to give you the chance again to introduce yourself if you want. You don't have to, but if you want to. Okay, Ali is doing it in writing, so if anyone wants to see the introduction, it's going to happen there. And Michael Ange as well, because he has some microphone problems. So I think we all went. So Oleg, the floor is yours.
What a lovely floor it is. So hi, everybody. So my name is Oleg. I kind of changed the spelling of my first name in recognition of the conflict in the Ukraine this year. I'm originally was born in Russia, but I'm Canadian, and I been living in Switzerland for the past 20 years, give or take. So a bit of a complicated life story, like I'm sure everyone else has. And when it comes to tech, it gets a lot more complicated, because I've been jumping kind of between programming languages and job roles and institutions a lot over the over the 2 decades or so that since I've been a student and then started a career in IT. And I think for the past 10 years, I've been involved quite consistently with open knowledge projects, and it's just given me a chance to come home, in a sense, to find my place among a community of peers like you who approve of and maybe even appreciate a plurality, a multidisciplinarity of backgrounds and approaches, which is actually kind of rare in some tech camps where people celebrate, how lovely it is to have an Apple computer, let's say, and that particular fruit company gives me really great hardware and really great software, and I could just live so happily in that world and never look outside of my rose-tinted glasses at anything else. And I mean, that very same thing happens also in the data world, right? When we look at things like SQL communities, even within like one particular make and mark of database, you've got people who are going to like conferences, and all their circle of friends are all people who work with the same database, and or let's say Hadoop as kind of another example. Everybody who works in big data kind of tends to work with kind of a broad range of tools. And so I'd say open data, it's not completely free of having the same issues. We do kind of start to tend to see the world as being this kind of openness or another kind of openness, and we start to frame things. It's inevitable part of the human condition. Our brain needs to simplify things. We need to classify and cluster things so we can understand them. But I do think that within the open data space, the Frictionless Data Project has been kind of a great, in German they say Lichtturm, like a flagship, initiative, which for me personally as a software developer, coder, it incorporates this fundamental promise of being able to hack at data no matter what programming language you're working with. And that's whenever I explain frictionless data to people, I often point to, obviously, point to the field guide or whatever we call the new website, and I often open up Data Hub, because that project by Datopian, for all its faults, and there are many, like for example their preference for Mac users, for another time, we can go into that a bit more. But it has that one particular part of it, the user interface, that when you open any data set and you scroll down, you have this nice row of tabs showing the code snippets in Java and PHP and Python and R and whatever other languages, and that's really, I think, what we need to show people, that you can work in any kind of technical environment and programming language, and you can get some kind of consistency. So I wanted to, Sarah and I were talking about these ideas with others here. I just want to thank Edgar and Augusto. Augusto's not here today, unfortunately. But we had this little chat last week or a couple of weeks ago, and we thought we'd bring this in. So Sarah says it's like Oleg's idea. It's not my idea. It's just something that I'm sure many people have done and over again. And maybe I'll share my screen and just show exactly what we've been talking about in the Frictionless Planet channel. To be specific, if you're already on our chat in the Slack or in Matrix, you can go look at it there. So I'm going to try to see if I can share my Chrome window. Is this working?
Yes.
All right. So the story for me begins, as it often does, at a hackathon. This was at the beginning of November. We had the now an annual tradition here in Switzerland, as it is in many other European countries. We have an open GLAM event, which brings together the community of people who work with museum data, library data, and so on. And we had a beautiful location, and we had a really cool event. Unfortunately, there was really like a person who got really sick and could not come to share their challenge with us. And we had to hack on it without an expert. So this particular challenge, out of the others that you can find on the website of the GLAM hack, it was kind of the situation where we had a little bit of Skype time, a couple of hours of Skype conversations with a person who was very knowledgeable about the data, but other than that, we were kind of on our own. And we were really interested. We loved the idea that there was this herbarium, which is like a kind of a library of plants, right? They're collecting plant specimens and they're putting them into a very careful storage. And they would like to connect it to Wikidata. Actually, they had kind of, so it was like really two challenges in one. One was kind of connecting to Wikidata, and one was making a map out of it. And we ended up hacking on it. This is our team. This was us working late into the night to try to come up with something. We made lots of notes and stuff, and you can see all this process here. And we got this data from them. In fact, they had already data, tons of it, like millions of data points, or let's say thousands of data points online. And one of the challenges was to connect it to Wikispecies, and the other one was to put it on the map. And so, long story short, we made the data package. You can find the data package here. It's called the Dataset of Herbarium and Vascular Plant Observations. It's published on GitHub, and it's a data package, right? So you got a data package JSON, and inside of the data folder, you've got actually not the complete data set, but you've got an excerpt of it. And yeah, it's like, looks like this. Right? And I mean, GitHub is great at showing like this table view on a data set, but obviously this is not what people really want to see. They want to have something more like, what you see on Data Hub, right? So you have like the summary, but you also have the ability to add some charts. What they see on Wikidata when you do a query, and then you can change the, you can do some graphs, you can put things on maps. They want to see a whole bunch of things. And you probably might remember that we had this data package viewer back in the day. I think it's no longer online, but and I think it's been kind of superseded by this view library for data package resources. But basically, there was this website, and you could feed in a data package into it and get a quick preview, kind of like a bit of an expanded version of the GitHub preview. What you're seeing here, actually, this is something that I built into DribDat, which is the hackathon platform I develop. And the data package, it's just like it renders here with the resources and little previews. So if I hover my mouse over these dots, they're color coded to indicate the format of the schema columns, right? So string and integer and whatever else you got, right? And it has a link to the license. So the data package viewer was kind of like this, but a lot more sophisticated. Yeah, so that's kind of the starting point to make a data package. So what's next? Well, next I want to go back to the original idea. We want to have this, right? So this is the screenshot of the final app that we made at the hackathon. It's just a typical map leaflet, with you click on it, there's a little tooltip. And it's the kind of thing that people are usually happy with after 24 hours of intense coding. Sometimes not. Sometimes and we had, obviously, if you keep scrolling down, there's like a whole Figma demo of lots of design ideas and so on. But to get the map working, basically, I implemented this quick and dirty frictionless data API. It's not that quick and not that dirty, but the idea is that you should be able to, like, with 2 or 3 clicks, turn your raw data package with a CSV file into a service, right? So when I'm talking about API, I'm talking about web service, which is accessible online, which you can connect to a simple application. And here I have it running on my computer right now, so that there's a deployment guide here on GitHub, which is it's based on Python, and you just go pipenv install and pipenv run python server.py, and you can start the app. But it also starts an API backend. The API backend just allows you to see the contents of the data package. So it's not the data package itself, it's not the schema, it's really the data, right? In JSON format. So you have here is like, the same things I'm seeing in the CSV, just as JSON rows. And JSON is, of course, much more convenient to anyone who works with web applications. But it's nice JSON. So it guesses it interprets the type of the column. It shows integers correctly. If it's empty, it gives you a null value. And even more importantly, it allows you then to do things like filters, right? So I can do I can take any one of these columns basically here, and I can say recorded by Frey, David, and it should work. Yeah, it looks like it's working. So now I only have the rows of the data where always this Frey David has recorded. So it's a simple API that allows me to quickly sort through the data. It's also paginated, so it's only going to give me, I think, by default 10 rows, and I can do something like rows equals 100, whatever, if I want more data. So the kind of typical things that you'd expect from a little search application. And the end result, is that you can make your interactive app nice and easily. So in this case, it's pulling the data from that API. And then it actually it takes one of the fields, which I believe is this one, this GBF ID, and it looks it up in Wikispecies and gets me the picture from Wikimedia Commons, which is referenced by the Wikidata API. So that's so the end result is like a combination of APIs, right? And so I've been since November, I've kind of tried to clean this up a little bit. And this is not my first attempt to do something like this. It actually started here. This is the Baumkataster data project, which is like from 2019 or so on. So I already took the data from the city of Zurich, and you see here in the GitHub repository, I even linked to the preview data package repository. But here already also had this kind of API idea basically in place. What I should say is that so the idea is that we have this data as a tiny service. You take this repository. It's actually a template repository. So, okay, I'm not logged in here in this browser, but if you're logged into GitHub, it gives you this like button says like use this template or something, and then you actually get it's like taking a fork, but it's kind of pre-filled as an empty repository, and it's supposed to guide you a little bit like a bootstrap to create your own little project. And then you just throw your data package JSON in there, you put in some files in the data folder. So they should be properly referenced. So the data package JSON should reference those files in the data folder. Or you can just add the API folder to your existing data package. That works fine too. You don't have to use this repository. Then you install these Python requirements and go. And in our discussion, we talked about the fact that so there's various ways of solving this. My particular solution is based on two Python components. One is Falcon, which is a very minimal micro framework. It's like Flask and Fast API, but it's like, yeah, it's supposed to be really reliable, debuggable, and fast and flexible, right? So it's fine. Flask is great. Fast API is great. I decided to use Falcon, and it works great here. And it provides the basic REST API service that makes it an API. And the other thing that's essential was the Pandas data package reader. So I am very thankful to Giuseppe and others who've worked to connect the data package libraries to Pandas. Pandas is, for those who don't know it, is from data science. It's a popular Python library for data manipulation. And you can, with this library, which it wraps Pandas in it, you can read the data package and then very conveniently extract its metadata and use it in your Python project. It's a little bit out of date now. Seems like I should, it needs to get a pull request accepted or whatnot. But basically, we could also just use Frictionless framework here. And what Pandas does is it adds this filtering and sorting and so on. So it just simplifies the process. The whole project is like, I don't know, like, let's see, 50 lines of code, 40 lines of code, right? So this is the entire code. Okay. It's a really simple idea, right? We read a data package and we throw some paginated JSON out. That's it, right? And all the heavy lifting gets done by these two libraries, Falcon and Pandas. Why is this a good idea? Well, if people are at a hackathon, they really need to quickly do more than just what you see happening a lot is people like they try to load the CSV directly using JavaScript libraries like what is it? There's this one called Papa or something CSV, and Papa parse, yeah, and that's fine. It works, but you struggle with these kind of issues like cores. When you have your data hosted on a different server and because of web security, you're not allowed to access it. And you also struggle with performance issues, because browsers they start to get weighed down when they have to load too much data into the tab, into memory, and if you're having to load the entire data set into JavaScript, you're that's going to really get in your way. Plus, within the let's say Python ecosystem, there are so many components you could add to this to improve the quality of the data on the fly. Okay, like for example, you could check whether it's current and provide an alert if it needs an update. You could check if there are if it passes the data package validation, right? And if there's an error, flag it to the developer or even to the user. You could do some kind of statistical analysis on it. You could shuffle it. You could optimize it, and so on and so forth. And of course, in our project, we're connecting it to a second API. So if you're going to be working with Wikidata API, why not start with a data package API in the first place? So anyway, like I said, I presented this at the hackathon. We created this template and at some point mentioned it. And by the way, thank you to Torben Wester. I don't think he's on the call today. He presented also in the past Frictionless community calls. He's a colleague of mine from Zurich, and he contributed to this as well. The discussion that we had last week with Edgar, with Augusto, was that I'm not the first person to do this. There have been lots and lots of other attempts, such as this one. This one is very new, so I haven't really looked into it in detail yet, but I mean, it looks very similar to mine. Like in 30 lines, someone being Edgar. Aha, so this is you, Edgar. I keep forgetting this is your weird GitHub nickname. Yeah. So, and maybe you could tell us how this code works rather than me walking us through.
Yeah, sure. Well, this is I did this experiment after your message on Slack. And okay. Yeah, but I was working on that some months ago with discussion with Adria from Open Knowledge, and the idea is converting a data package to SQLite. I'm using this CSVS convert. It's a Python library that uses Rust library behind the scenes to do the conversion, import, convert the data package as SQLite DB. And I'm using dataset. That's, I don't know if everyone heard about the dataset as a really nice piece of software on Python. And it's basically give you an interface on the web for your data when you have a SQLite database. But it also gives you API, a JSON API that you can query and do whatever kind of query that you would be possible in the in a SQLite database. Yes, and the advantage I would say that using the dataset is that everything that who knows how to query your data using SQL, you know how to do it in the dataset. But of course, like most of the people that work in data use Python, and maybe the pandas is going to be easier to create a query. It's pretty similar, the idea with Oleg. And there's a bunch of
I'm getting a bit of a demo effect here, but this is the one. So you mentioned in the chat that there's this website lite.dataset.io.
Yes.
And you can feed in. So I just took a CSV file directly from the raw. So I went on GitHub. Where was it? Just one second. I went on the Baum Katash. I mean, I went to the project which I showed you before, and then I went to data. I went to CSV, and then I just clicked on raw.
Yes.
And I took this URL, and I posted it after the CSV link. Yeah. And I get this nice preview here, and these are the links to the JSON API here, right? This view data as JSON CSV.
Exactly, but you can do custom queries your data. There is in dataset documentation you describe how to transform a SQL query in a valid API query. And yes, and this dataset Lite is using WebAssembly and IOD to convert to Python on the fly and download all the dependencies. Is of course a little bit heavier and slower than if you use dataset locally, but you can host yourself on your server the dataset.
That's really cool. So you got both options. Yeah, I did notice it took quite a while to load up on first time.
Yeah, because it downloads all the dependencies from Python on datasets and compile on the real time there.
And dataset is quite like it's very close to SQL, right? So it's for people who are used to writing SQL to query their data. It has a nice visual interface, which I was trying to use here, right, to do searches.
Yeah, there is a bunch of plugins also for map, geospatial data, or plugin with plotly visualization, or other kinds of visualization, and its dataset is similar idea of let's say like SICAN, but give you power to a user to share a dataset. But when you don't have a lot of data sets, you want just share in a nice way your data, you can use dataset for that. So I think New York Times used it. I think it was developed when I forgot the name, was working in New York Times.
And would you say that you could use this for like a production app? Like would you use this as a backend to serve an API for production?
I would say so. There's a bunch of productions scenarios that they are using SQLite. When, of course, when you don't have a lot of write, yes, because usually SQLite is more focusing, you have a static database and you want to provide it. And yes, much simpler than if going to a MySQL or Postgres database. And it's pretty fast, pretty stable. And could you in the discussion you mentioned this other project on GitHub to right? So to convert, download the data, script data, and put in a repository. And this idea was based on the idea from the same guy that created the data set also. If you read about it, I forgot the names.
Simon Wilson.
Simon Wilson.
Yes, Simon Wilson, exactly.
This one, flat data.
Yes.
No?
Exactly. This one, this idea is, yeah, they say this Greek script and Simon Wilson is the guy that created data set. He worked in Django also. He helped create Django.
Yeah, this is really exciting. So it's kind of a GitHub experimental project, and you can just throw in a GitHub repository, choose one of the data files inside of it, choose a commit, so it has the version, the GitHub versioning, Git's versioning built right in, and then you have your API ready here. So, no, this is original API data source. You have then this kind of like cool modern view into it. I think you can expand these and stuff. It's like interactive, and then you can download it and stuff. So it's still a relatively new project. It also has an editor and an action for doing GitHub automation tasks around maybe cleaning up the data or checking, validating it. And it would be really cool to see if this can work well with Frictionless. I'm this is very it's like much closer to GraphQL and these communities. I think maybe we're competing to some extent, but I think there's definitely overlap, and we should keep an eye on what's going on here. And the other thing I wanted to point out is, of course, CCAN. CCAN has APIs, right? And for example, this project, which I've been maintaining for a couple of years now, takes the same approach, making a simple API, making a simple widget front end, but it talks to CCAN's package search, right? So you can just put in a keyword, and then you get the rows of data. And this so we have CCAN.js for talking to CCAN out of JavaScript, or what's also quite popular is this CCAN-R art script, right? So I use this often in school, right? At the university class, which we teach, where we usually use R. We use the CCAN-R library to to do a search, and then actually to get the to actually download the data through I mean, the download happens locally, of course, not through CCAN. But again, you kind of the intent here is to start with an API and very quickly end up with an environment where you're working in your data. And usually when I show this to students, I say, well, look, I mean, in this way, I mean, they say, well, why don't you just download the CSV file and put it into the same folder as your code? And I say, well, look, your data is immediately out of date. It's immediately an old product. And from an open data activist perspective, this is in like a serious problem, because you're just not going to know when it changes, when it disappears, when the format gets broken. You really want to always try to work with live data. And yeah, there's pros and cons. You should probably cache the data, not just rely on remote CCAN instances or GitHub for that instance, right? GitHub goes down as well. Twitter goes down. Everything goes down these days. All right. So an API is a nice buffer. It brings in kind of engineering best practices, right? And the kind of questions we were just discussing, things like automation or production requirements like security and scalability. That's what probably would go into having a kind of a concerted effort to create a service for data packages. I have to say one other thing, Open API, Swagger, right? That's been kind of the de facto way to create APIs in the engineering community, like from Cisco to Microsoft to all these other people. I mean, everybody who works with APIs kind of, knows about this, that it's a lot like the data package specification, right? It's like this document which explains, how do you define an API? What is an integer? How do you attribute the license and so on, right? This looks very familiar, right, to anyone working with data packages. And I think that this is also a chance for us to maybe connect the dots a little bit, maybe with this discussion to see where do people, like maybe even folks here on the call. I mean, are you working on web engineering projects, or what do you think when you see kind of like these worlds colliding, where everyone wants to have nice, scalable, reliable services for their apps with different requirements, and where should we go as a community next?
Yeah.
I'll stop sharing.
Sorry, just a comment. I shared this link as a project that I used for years, Postgres, and it's also, you can import in a Postgres database data package using the Frictionless framework. There is an extension that you import it, but after your data is in the Postgres database, these tools like magically create a RESTful API, including the Swagger JSON describing your interface. You have a nice visualization and self-documented for your data, and you can do any query, patch, update, whatever. And of course, if you want to put in production, you can restrict the update data commands. But yeah, it's another solution. It's a binary. It's a program created in Haskell. It just give you the endpoint of your database, and automatically you have a RESTful interface, and it's pretty stable and pretty fast. It's another solution, I would say.
Okay, thanks, Edgar. I think we have a question from Nick, and then there's a question from Peter as well.
Thank you for the overview. That's really interesting. There's obviously a lot of different options here. From our experience, again, working mostly on the climate change side of things, we started using Frictionless in the most obvious way, which is to validate the data coming in. And it's very effective at that. But now we're really trying to focus on how to get the data out. And what we're seeing a lot of is for these kind of workloads, there's a web interface, which is pretty much read-only. You're trying to get reports on climate impacts and things like that. And then there's this sort of data analysis side. They're dealing with AI models. They want to be in Jupyter notebooks. They want to use Python and all this stuff. So it's almost like there's this, you might start off on the website and it might give you some tools. You download locally, you work on, and then you might publish some of that information back. There's a kind of a two-way loop that we're seeing. And so the reason that that's interesting to us is, first of all, it means that this data needs to come out of the application in a variety of different ways. And one of them is certainly the open API. We're also looking into OData, and there's other standards as well. But just having a few common standards that you can use to get the data out. And in my head, I'm thinking, maybe there's an endpoint that allows you to download the Frictionless data packages as well, because you could want like an archive version of the CSVs at a certain point, and you certainly want to describe them. So I almost think of that as being a requirement of any application on the website. Open API, download the Frictionless data sets, maybe something else like OData. But then on the data analyst side, working locally, I think that they would want to be able to download some of these tools, and then they want to make changes and bring it back. And so I think that Frictionless is needed on both sides, because if they're publishing back into the system, then it's going to need to get validated. So, and then the other comment I would make finally is that in order to do a lot of this stuff, organizations are now trying to work together using increasingly a concept called the data mesh, where you focus on building a domain and being responsible for the quality and the accuracy and the validity of the data in the domain. And the domain might be banking, or it might be, municipal government, engineering projects, or whatever it is. But the point is, it will probably be increasingly a requirement that you share some of your data publicly, some of your data privately, maybe some of the data is premium. And this data mesh concept is an interesting one, because again, I think it's a good position for Frictionless to be in, because you really need to describe what's in your domain, and you need to give people confidence that the data makes sense. So these are just ideas that we're running into, but the reason that they're happening is because the climate change impacts are so varied. They involve physical sciences, very complicated technologies. They're data driven, a lot of local data combined with government data. And all of that is the sweet spot, I think, for frictionless type stuff. So anyway, just some comments on that. These are more thoughts than anything, I guess.
Thanks, Nick. Peter, I saw that you were already in a conversation with Edgar, but I don't know if you wanted to ask anything else.
No, it's on the multiple resources. Yeah, I think most of these services, it makes sense that they're starting from a flat file and then you can query on a flat file. But the use cases I have are with related resources in one data package. It would be nice that I could just point to a data package JSON and say, hey, can you create a service on top of the resources in this data package and then have an endpoint for each of the resources. But yeah, I don't know if you if that is possible in your service or any of the other services.
It is. I forgot to mention that. Thanks, Peter. So it really creates an API endpoint for every resource in your data package.
Okay.
But it doesn't go as far as understanding interrelationships between the resources. If that's what you're asking.
Okay. And the other small thing is you threw me off a little by saying, oh, the data is on GBIF, and then we have it on GitHub, and then we build an API. While GBIF also has an API already where you can query the data and have metrics.
Thank you, yes, sorry. It's yes, we didn't. Thank you so much. Yes, it was a project which involved a lot of data sources, and GBIF is of course the world's largest biodiversity database with 2 billion something observations, and basically our colleagues from this herbarium, they're already publishing to GBIF. They also gave us a direct export from their whatever it is they're using internally. I can't remember, but yeah, thank you for the correction.
Okay, cool. But otherwise, cool software.
And also, I just want to mention that, Peter, the question that you asked in the Zoom chat, that is it a service you need to host yourself? Is there a service like DataSet? It brings me to the obvious thing that we should, like the data package viewer, which is like the central viewer that anyone can use very easily, like the DataSet Lite viewer we just saw. There should be definitely like a very quick service anyone could just plug in a data package into and get like a little widget they can embed on the web page, like I showed at the beginning, or a full-blown preview. So thanks for that.
Great. I think Keith has a question and then Dan. Oh, Keith, you're muted.
Thank you. Great presentation. Thanks for sharing it. A couple thoughts. The first, it seems like this kind of overlaps with another problem that I think people are tackling and is worth tackling, which is creating a data repository for frictionless data or data packages. And if you can render one data package, right, or then you should be able to render a bunch and render galleries or collections of them. So we could potentially try to solve both problems at once. And then this also, well, I guess maybe two more related thoughts. You're talking about being able to quickly render things even if you don't have the ability to run a web server, you know, which is probably the case for many people. It would be great if we could find some funding or someone who would like to support that, and we could set something up like Shiny Apps where you can quickly just like upload something and have it rendered and share it with people. That's not like technically it shouldn't be too hard as long as you have some constraints on the data size and resources. It's just a matter of literally finding the money. And then the third thought, so all of this gets me back to what I was interested in early on. If any of you recall what I presented a few years back, I think on bio, like specific data, I think it would be interesting in this, it fits in with this a little bit to, again, think about ways we could potentially extend frictionless for domain specific applications. Because then what you could do, this actually connects with what Nick was talking about with the meshes, data meshes, which is that instead of just having generic like plots, like a scatter plot or something like that, if you just have any sense like, oh, hey, this is this type of data, you can now render a plot that makes a lot more sense for that type of data, or a table, or just know kind of how to handle it generally. And it's not that hard, right? Like at least in the domain I work in, there are some standard data types that people use everywhere. And if you just know the name of it, you can choose things that make a lot more sense to render. But there's not really, we haven't talked about it or agreed on anything right now. So that's the first step. Yeah, but all in all, great. And if you'd like any help with this, let me know. In particular, if you want to try to tackle it on the scale of both doing like repository and single instance. And then I think also more generally having an API that you could then create multiple front ends for. So when I think about this and when I've tackled it in the past or attempted it, I try to create like a Python backend that I can have a web end on top of, but also render on the command line and so on. And again, I think like some of those problems you can solve in one place and then use in multiple endpoints. Sorry, that was a lot.
No, thanks. I actually shared also the link to the presentation that you gave in the chat if anyone is interested. You can go and have a look. There's a recording as always. Dan, I think you also had a question.
Yeah, I was curious if there's been some kind of testing or research into like the scaling limits of these different solutions. Like the work that I do with CMS, it's just a lot of, people doing work with very specific tooling or moving data around from like one contractor to another in the federal kind of procurement universe. And there's just a lot of very large CSV files moving around. And just a large portion of our energy goes into building solutions for, kind of pipelines that get triggered by there's a new version of this CSV file. So now we need to update the metadata. And then like our kind of service is built on a MySQL database that the CSV gets imported into. So there's just like a lot of work into optimizing background processes to, import a CSV into MySQL and update like which version of the data the catalog is pointing to, all that kind of stuff. It's a very it's an overly complicated system that we want to simplify, but we're kind of looking for the right approach. So yeah, I don't know. I'm sure some of these solutions break down when you get to a certain point. And like, just for example, the project I'm working on now, there's a number of CSV files that are about 7 gigs and have about 10 million rows. That's, it's like all of the payments to physicians from drug companies in 2021. Like it's kind of data sets with that kind of data that are just inherently large. So how do any of these solutions scale up to that kind of thing? Or are they more appropriate for, a smaller data? Yeah, I don't know if it's like feasible to host that kind of data on GitHub, for instance.
Dan, quick point. If you're using CSV to actually store stuff for that scale, I would definitely check out any of the arrow-based formats. So Parquet and Feather are going to be a lot more performant, read, write, and file size. And you can also stream chunks of data or columns of data.
As an alternative, yeah, okay, I'll look into that. Thanks.
And in the frictionless community, there have been discussions also around how to stream and pipe and all that. But I think you bring in an important point that I really forgot to mention, that I think there's like in the open data activist sense, we have like these two needs. One is just show me your data. Right? Like I want to know what your data looks like. I want to get a feeling for it. And I'm just happy with a small sample. I'm happy with an excerpt. I'm even maybe happy with just a specification. Just show me your schema, And on the other hand, yeah, I want to tap into the data riches, of Amazon, of my government, I've actually worked on exactly the same kind of type of data down, so we can exchange field notes at some point. But I want to just use the opportunity to invite you to consider coming to Germany, to Switzerland, not Germany, to Switzerland. Germany did this last year already. They had this Bund API hackathon, and we're planning one at the end of March. which was actually originally called the API Hackathon, because we've been working on creating open data events for years now, and then we kind of with a lot of these these federal institutions, we've kind of started getting to the next level where people are realizing, okay, it's not enough to just throw some open data over the fence. Let's get people to work with their APIs. And as soon as you start talking to APIs, you're talking about some kind of engineering contract. You're talking about much different technical requirements and so on. It ups the game in some ways. And anyway, we're going to have this hackathon. I'll put the link in the chat afterwards, and you're really welcome to join us at the end of March. I think Nick has a question.
Yeah, Oleg, on that point, I was kind of hinting at it earlier, but for some use cases, and it's actually, I think some of the use cases that we're hearing on the call, certainly the ones we're experienced with, because the data is scientific often, or because it involves the physical world, because it's geospatial, because it's inherently complicated, Frictionless is solving a lot of the needs around helping to understand it and certainly to make sure that it's valid. But what I find interesting, and I really love the presentation today, I'm almost looking at these applications as having a series of capabilities that's almost on a spectrum, because it's impossible to find one size fits all. You mentioned, the sample. That's actually a real need to see, just show me the first 100 rows so I can make some sense of whether this is useful or not. So having that logo, that icon, that animated GIF, or that sticker is brilliant, because that ticks that box if that's what you're looking for. From there, you might want to download a sample of the data. So now you have to download the Frictionless resource file, and that's an endpoint, maybe on an S3 bucket or something you can get to, right? So that's another use case. Then you want to start to explore parts of the data. So maybe there's an API that through OData or something like that allows you to do filtering of stuff. And then there's the other scenario where you just want to query everything and then start to do more things. And then you want to upload these data sets, back. You want to contribute back and so on. So the way that we've been seeing a lot of the applications, certainly recently, is it's harder, but you need to do all of these things, because you're never going to make one part of the audience happy, and they eventually are probably going to be, the more they use your data, the more they're going to be touching on all those use cases. So I guess it's challenging, but a lot of these technologies do exist. You've shown lots of examples of that already, and maybe the conversation is more around, and actually to your point earlier, I think, Keith, about extending the schemas. It's harder to do all these things, but if we do all these things, people are going to use the data and certainly get value out of it. Whereas if we just do one of these things or another of these things, it's not the whole story.
Keith, go ahead. You had a question also.
I'll just jump in and say, so that you talk about there's being this desire to preview the data, and then there's kind of a desire to get the full data. I would also say that there's maybe room for something in between, where a lot of the times you could coarse grain the data and sample a subset of it and render, density plots and things like that. And that's going to be a lot more informative than looking at the 10 first rows or whatever. And those are things you could pre-compute and cache and do very efficiently.
Dan.
Yeah, this is sort of an anecdote. Well, choosing my words here, since yeah, I think that we think that there's basically like a user persona out there that is like somebody that, for these large data sets, that there are people that are kind of familiar enough with the idea of kind of poking at large data sets to get insights, but aren't really, it's actually more challenging. I'm discovering that it's more challenging than one would think to download a CSV file that's, let's say, bigger than a gig and like do anything with it. Like Excel won't even load it. There's like kind of a universe of alternative tools that will, but they're not like well known, like a lot of people just don't even know about them. So like I think somebody that like uses Excel at work is like knows kind of like how to look for data within a large tabular resource, but they run into a giant CSV and like they kind of get blocked. So I think we have an assumption that like, that providing a like pretty robust tool to do that kind of analysis on the website is actually worthwhile. We're trying to figure out how to even confirm that assumption, but that, yeah, I think that's like a good use case for some of these tools that like maybe they're not going to write their own application that, you know, uses the API to power itself, but just in the sense of like, oh, look, the government has this data set. I wonder, you know, if there are payments to doctors over $100,000 in my state. It's like, I think it's potentially pretty great for people to be able to just have a way to ask that question if they have kind of an intermediate level of kind of data skills without having to download this enormous data set and figure out even what local tooling to set up to get that insight.
You sound like you're pitching a Chat GPT project or a hackathon.
It's crossed my mind, believe me.
Thanks, Dan. That was a very good point, but I'm afraid that we came to the top of the hour. So I think we'll close it here. Before we part for our winter break, for those that are taking a break, I just wanted to announce that the next community call is going to be on January 26th. And we're going to hear a presentation about frictionless and DCAT data from Matteo Fortini. So yeah, put that on your calendar already. And then I don't have any other announcement really. Thanks all for being here today. Thanks, Oleg, for leading the conversation. That was excellent. I wish you all a very, very good break for those of you who are taking a break. And I'll see you again on the 26th of January, I think. Bye all. Thanks.
Bye, everyone.
Bye.
Happy holidays.
Happy holidays.
Bye.
Happy holidays.
Happy holidays.